I was gonna say is it gamma times the speed of light, that would be how fast it's traveling.
Beta times the speed of light would be how fast it's traveling.
Right.
Is it 8 meters?
It is.
How'd you get
I just took this LP equals gamma times L, did 16 divided by gamma
Yeah.
to get the not proper L.
Yeah.
I'm just do you use the calculator to do that?
Unfortunately.
I can stop anytime. All right, so from the bar's point of view, the pole is 8 meters long, so it has 2 meters to go. So traveling at that speed, how long will it take for the pole to hit that door? Well, I know that distance is equal to the rate times time. We're not dealing with any acceleration here. And so the time would just be the distance divided by the speed. So it's 2 meters divided by a speed of 0.866 times 3 times 10 to the 8th meters per second.
I got a very small number, which would make sense, I think. 7.7 nanoseconds?
It should, I think it's nanoseconds.
Yeah, because it's in the negative nine.
All right. So we now have 3 positions and moments when these events happen. And all of that is from the Barnes point of view. Now, let's do it from the pole's point of view. So that was Barn, this is the pole. All right, the left door is going to close. Remember that the left door closes as soon as the left enters, and so that's going to happen at 0 meters because from the pole's point of view, this is 0 here, and the door closes when it just gets inside. Now the pole has to establish when time is equal to 0, so it's just going to establish 0 nanoseconds. It's going to basically start its timer at the same time as, they have the same time reference. Now, the right door closes. We use our equations over here. I know that the prime frame is the, let's see, what am I doing here? We end up with, because one will give us a very different answer than the other. So the right door is closing, that is the barn, so I want, so x prime is equal to gamma, which is 2, times x, which is 10, minus our speed of 0.866 times 3 times 10 to the 8th, times time of 0. I can do this one, 20.
20.
Meters. At what time? So let's plug down into here. So t prime is equal to 2 times 0. Again, just plugging in that value for time. Minus, it's 0.86 v here is 0.866 c, so it ends up being 0.866 divided by 3 times 10 to the 8th times x, which is 10. So what is t prime?
So what's up with my order of operations here?
Yep.
I had a tiny negative number, does that seem right?
Oh, my number, okay, yeah.
If you multiply times 10 to the 9th, so you're looking at nanoseconds, what is it?
I have negative 5.8 times 10 to the negative 9 nanoseconds.
5.8 times 10 to the negative 9th,
8, sorry.
negative 8.
Yeah,
All right, so negative 58 nanoseconds.
I don't know that that's correct.
That's what I got. I should have been more confident. I just didn't think that was right.
Okay, I share wrong answers all the time.
I just didn't think my time should be negative.
Yeah.
What is the same? Because remember, just because they happen at the same time in one frame doesn't mean they happen at the same time as another frame.
Yeah.
The right door is going to close before the left door closes from the pole's point of view.
Oh, okay.
Now let's figure out when the pole hits it.
And so, sorry, what made you choose the prime equations?
The prime is, well, that was set up as x and t, and this was x prime and t prime.
Oh, okay.
I mean, that's
was
a
it.
bad reason, but
Okay. Yeah.
I'm confused how we have it to the negative 8th, but we concluded that it's nanoseconds. I thought nano was to the negative.
I moved the decimal point.
Oh, I'm sorry, I missed that.
So, like, make that 10 to the negative 9th, then multiplied that by 10. I divided this by 10 and multiplied this by 10.
Okay.
So it's 58, negative 58 nanoseconds.
I see, okay, thank you.
I'm going to sort of, I know you have a question hanging out
That's
there,
fine,
but
yeah.
I want to finish this and then we can debate philosophy.
Okay.
All right, so now the position of when the pole smashes into the right door, it won't be the same as this right here, because remember that the pole has moved by then. So the right door closes when the end of the pole is here, but now the pole is going to move this way. And so the position will not be 20 meters. Again, plug it into that equation there. So we get x prime is equal to 2 gamma times x, which is 10, minus v 0.866 times 3 times 10 to the 8th times time of 7.7 times 10 to the negative 9th. Should be a positive number.
Got 16.
And the time that it hits the right door. Running out of space here. And so t prime is equal to 2 times t, which was the 7.7 times 10 to the negative 9, minus 0.866. The c's will cancel out, so I got left with 1 on the bottom, times the position, which was 10.
I got negative 4.2 times 10 to the negative 8th.
So negative 42 nanoseconds.
Yes.
So from the pole's point, from the Barnes point of view, doors close at the same time, and then 7.7 nanoseconds later, the pole smacks into the right side. From the pole's point of view, the first thing that happens is the right door closes. Then the pole smacks into it, and then the left door closes. That happens first, that's next, and that's next. So back to the car and garage problem. yes, from one point of view, from the garage's point of view, the car fits inside it. From the car's point of view, the barn has shrunk, and the order in which various things happen is different. And that was incredibly vague. But basically, the right end of the car would get to the far end first before the left end got inside. Which makes sense. I mean, if you're driving something that, if you're driving from the car's point of view, 11-foot car into a 5-foot garage, you're most likely going to be hitting the side over here before you get the back end inside. This is the nature of reality that you've been living with. You just haven't noticed. The only other thing that you would need to know for the relativity assignment is the Doppler shift. I'm just going to give you the formula that if the signal's coming towards you, whether the for the signal coming towards you, the observed frequency is equal to the frequency of the set frequency, or of the source, times the square root of 1 plus beta over 1 minus beta. That's for the source coming towards you as it sends out the signal. I don't think the derivation is necessary in order to do the problem, so because I had all that extra time, Friday we'll do the relativity assignment. I'm not going to post it, just because the fear is that somebody's going to do it before they walk into class, and that's going to rob everyone of the conversation that's going to come out of it. So I will bring it with me, hand it out at that point, just because I'm really
You need
doing
raw
like
answers.
Pardon?
Raw answers, raw thoughts.
That's right. It's basically physics raw.
Yeah.
And on that note, it actually is class over. Despite the earlier rumor, it now is happening. I was just ahead of my time.
Yeah.